Hey everyone, it's Miss Lloyd, which you should already know because you're on my YouTube channel, or I sent you this video and I'm forcing you to watch. Well, not forcing. I mean, let's be honest, not all of my kids actually watch my videos, but you know what? Sucks to be them because this is awesome. All right, so we're looking at mathematical modeling and variation. So typically, whenever we have a bunch of data, it's really great when we try to predict things based off of previous patterns. So a lot of time we'll like have a bunch of dots on a coordinate plane. So here's my coordinate plane. Here's a bunch of dots that are my data. And so we start to figure out, okay, this looks like it has some kind of a pattern. It looks like it's going up in an upwardly direction. I could draw this line and it goes through a good portion of my points if, or through the middle of a bunch of them. And so I could use this line to kind of represent my data or represent what's happening or maybe even tell the future. So we use this thing called a least squares regression line. We can also talk about direct variation versus inverse variation. These are ways to describe relationships, so then we can tell the future for a given situation. The more you can tell the future, the more money you will make. Fun fact. So then this first one I'm going to show with my students because I have this really handy dandy calculator on my computer, and so I can show them exactly what buttons I'm pushing at each time. So with direct variation, there are multiple ways to look at it. So they will tell you y varies directly as x. So it means that we're looking at this formula, y is equal to k times x. X is multiplying with something in order to get our y value. And so we have some constant k. So it's like 7 or negative 42 or 11 over 12, something like that. And that k is called the constant of variation or the constant of proportionality, because we could also say that y is directly proportional. Oh my gosh, I've been talking all day and my voice is going. It's okay. I'll get through this. I gotta get through this. I gotta get through this. All right. So inverse variation varies inversely. We're doing some division with the constant in order to get our y value. So the constant divided by x, or we're saying things are inversely proportional. And again, k is some constant number, so some number that's going to stay the same all the time, like 7 or 49. We also have combined variation, so y could be directly proportional to one thing, but then inversely proportional to another. That's totally fine. You can do both. Both is not a bad thing. And then there's joint variation. So if z varies jointly as x and y, as you will most commonly see it, or if it's jointly proportional, it means x and y and k are all multiplying together in order to get z. All right, so then next bit, here's some examples. So our first example, y is directly proportional to the third power of x. So the directly proportional means that we have y is equal to, and there's going to be some multiplying with our k value. So k is going to be multiplying with this part that comes next, which is the third power of x. So x to the third power is basically what that's saying. Why it has to be so complicated is the third power of x. I have no idea why it's x to the third power or x cubed. So we have this nice little equation here that we're working with. We don't know any of the variables. We also don't know the constant. So then the next part, they tell us, oh, hey, when y is equal to 750, x is going to be 10. So then over here I say, okay, well, I can plug in 750 for my y value. They also told me that my x is 10. I made that in blue. So then now I have everything but the k, which means I could solve for k, figure out what the constant is, because it is called a constant, it means it doesn't change for this particular problem. So then 10 cubed is 1,000. Gonna do some division to get that k alone. And my k ends up being 0.75. So I'm gonna rewrite this equation with my now constant that I now know. So then the last thing they want me to do is to find the value of y when x is 8. So now I only have the one variable here that I now know, so I can solve for my y because I know the constant, because it is constant, which means it stays the same. And now we are done. And that is how you do the thing. It's awesome, right? I thought so. Round of applause happening now. All right, So next we have if something varies inversely. So if it varies inversely, that means I have some division with my constant and my x. They then go on to give me some more information. They say, oh, hey, when y is 4, x is going to be equal to 16. So now that I know my x and my y, I can figure out what my k is. So I'm going to go ahead and solve that, and you can do it yourself and check after I've solved mine. So you could pause and do it yourself and then check it out. Now I have my new equation with my k value. So then the last thing they want me to do, they're like, oh, hey, by the way, we want you to figure out what y is when x is 10. So then now that I've got this new handy dandy formula, I'm going to plug in a 10 for my x and solve for the y. Why? Because I said so. And then we're done. These are pretty nifty if I do say so myself. Next one, we're looking at something that varies jointly. So again, remember jointly, this means we have a joint household. We've got a lot of people living under the same roof. That means that there's less chores because you can share. Sharing is caring. All right, so then I've got my varies jointly means everything's multiplying together, my x and my y with my constant k. And then they give me some more information saying like, hey, when we have z equal to 10, then our x is 4 and our y is 15. All of this happens at the same time. So then they give me all of this information so then I can figure out what my constant k is. It's like there's a pattern to the madness. Oh no, method to the madness. That's how that's supposed to work. Pretend I said that. Now that I have everything plugged in, I'm going to solve for my k. So now that I have my new k, I can fashion myself a new formula. And then they want me to figure out what z is whenever my x value is 12 and my y value is equal to 7. So I'm going to plug in 12 and 7 and then figure out what z is, like they've asked me to do. Now that I've found my z, I am done. Ta-da! All right, and then the last one I'm going to go over, because I'm going to do this other stuff, it's a little bit more of a doozy with my kiddos, because I like them more than the people that I don't know. And I've already discussed this. I feel like I'm going on a tangent. Anyway, so neglecting air resistance, the distance, which they have decided to name S. Why they decided to name distance S, I have no freaking clue. It bothers me so much, and I hope it also bothers you so that I'm not alone in the world. Comment below if it also bothers you. All right, and so the distance that the object falls varies directly. So it varies directly, and I'm going to have some multiplication in there, as the square of the duration. Duration being t actually makes sense because like t is time. So the amount of time that it takes to get to the ground. So then my distance, oh, again, s, and also my s's look like 5s. So I'm really sorry. That really bothers me. And then because it varies directly, then k is going to be multiplying with the square of t, so t squared. And so they told me here, after I complained about many things, because that is what I do, they told me that it fell a distance of 144 feet in 3 seconds. So they've told me a distance and they've told me a time, so I can figure out my constant of variation. So now I can do some solving and stuff. So now I know my constant of variation. They want us to figure out how far of a fall something is taking whenever it fell in 6 seconds. So I've got a new t, and I'm trying to figure out the distance. S. Why is it s? That bothers me so much. Not that you didn't already know, because I keep constantly complaining about it. But what else am I going to complain about if I don't complain about the fact that they decided to make distance s? All right, and then we solve. So for this situation, we do actually have units of measurement. So because we're talking about distance, everything, all of our distances have been in feet. I want to make sure that I put feet here. For my students, the poor, poor dears, if you're not my student, you should feel sorry for my students. Anytime they don't put a unit of measure, I assume tacos, and it's never tacos. Have you ever done a word problem and they're like, oh yeah, it's 1,700 tacos? It's not. It never is. And then they make me think of tacos because they haven't written units, and then I assume tacos, and then I'm hungry. And so hopefully you guys got something out of this. If you did, please like and subscribe. If you would like to send this to someone else to maybe torture them, or because you feel like it might be useful, please feel free to share it. Spread the love.